Okay, so welcome everyone in the third part of the, exploring terminal info. First of all, does this work? Can I hear myself? I can hear myself, which means I don't need this anymore. So let's get to it, I guess. First, like a really fast advertisement. In case you speak Polish, then I'm actually doing an intro to programming in Python, like just for beginners. Next week, it's for free. If you want, you can sign up for free. 4 days or rather 4 evenings, and it's like absolute Python intro for like if you never programmed, that is something that might interest you. But we are here today to play more with the terminal. And what we were doing last time is this really hacky compiler, which would, well, basically take a Python function, this function to be exact, and then compile it into Terminfo VM, well, language, bytecode, whatever you want to call it, like instructions basically. And I've done it by using the Python's disassembly module, which actually can grab the bytecode of a given function, and then I just like translated the bytecode or the pieces of the bytecode from Python, like for example load fast, into this like percentage-based language for this Terminfo VM. So there isn't like this works because it's a stack machine. Like both things are a stack machine. We looked at the source code of the stack machine in Terminfo a little bit yesterday. Obviously, Python is much more powerful as a stack machine than, rather CPython I should say, than Terminfo, but that doesn't matter. It can still work. Like as long as I don't use any fancy features here, it's going to, like it's just going to work. Is this how PyPy works? I honestly don't know how PyPy works, because PyPy, I think, it might be doing it a little bit differently. But, like, for example, I've written some obfuscation engines before, which would also go and look at Python's functions bytecode, and would start messing up with that in some pretty creative ways. I know also some Python fuzzers, as in fuzzers which work with CPython programs, also do that. Also they use like look into the bytecode. Now actually PyPy might be doing something a little bit more advanced than just like this transformation which is done here, but that's okay. That's a different topic. So let's go back to where we were yesterday. So I think this worked for what it's worth. Yeah, like it can translate this function here to this. So just to verify, put on the stack parameter 1, p1 was the argument of the function, put on the stack 3, and then run a multiply operation, like grab 2 things from the stack, multiply them, and put the result back on the stack. So this is an equivalent of this part. Then we have put 10 on the stack, so now we have the result of a multiplication and 10 on the stack. Do an addition, which is now an equivalent of this, and then put it in A being a variable here. It supports only variables which are 1 letter, both capital and lowercase. These are like different sets of variables, so this is fine. And then we get that variable and we do a decimal, print it out as decimal, which is the equivalent of this. Like outd does not exist, it just translates into this opcode, D being for decimal. Now, what I actually want it to do, or rather what I want to do here, is I want to change, I guess, well, I need to add a couple of things. I need to add, what does this even support? That's a good question. So man terminfo. And let's look for %p perhaps, yeah. What else do I want to support? I need outputs, like in general outputs, not only percentage, but in general. then I want these format strings to be fully supported as well. So I need like, I'm going to change this out function into some print function. Let's say print is fine. I think they called it in the VM safe output or something like that, but I'm just going to call it a print. And then I guess I can like do, oh, this is like just another print. Do they have C here? No, they don't. This doesn't work as we established yesterday. This we have supported. This we have supported. These are the variables. Constants. We can support constants. I don't think I care much about them. I can always like just recalculate this. Integer constants we already support. This is strings, we don't support it. Arithmetics, we all support all of them. Bitwise operations, we don't support any bitwise operation. This is something we should do. Logical operations as well, we have to support these. I don't think we are going to support these at all, because I don't think there's a way in Python to actually achieve this without relying, and we don't need them, so we don't care. Unary operations, also something we should support. We don't care. And this is going to be a little bit more of a pain. This is like an if else. We have to basically, so if we write like if then else in Python, it will be quite a lot of different instructions which are going to, you know, make conditional jumps and whatnot, and we'll have to figure out how to squeeze that into this kind of program. This shouldn't be too hard, honestly. So yeah, I think it's going to be fine. There's a question in Python, can I implement C-style bit fields? I have 128-bit payload made of 4-bit field. What's the idiomatic way to unpack this? Okay, so I don't think there's any great way to do it. The way I would normally do it is like, just like Python supports big nums or big integers by default, right? So which means you can put the 128-bit number into an integer, and then you can just shift and grab 4 bits, shift, grab 4 bits. If by any chance you have access to the mastering binary files and protocols course, the one on HackerCana, in workshops, yeah, like this one, if you have access to this one, it is pretty expensive, but I think lesson like 2 and 3, and then also the part about programming this in Python has a really good tutorial on all of this. But long story short, you probably just want to do something like, let's assume this is this number, and then you do like, if you want to get nth field, like let's assume n is going to be 4, then you just shift this number by we set 4 bits. So okay, 5th field, counting from 0, so 0, 1, 2, 3, 5. We multiply it by 4, so we have 20th bit. We shift the number by 20 bits left, and then we set 4 bits. So to get 4 bits, we do this. This is an equivalent of this mask. And yeah, this is how you extract it. I don't think there's a better way to do it in Python. There might be using C types, but honestly, I would just make a function. I usually recommend making a function which cuts out a piece of a number, like you tell it, I want bits from like 5 to 7, or like 7 to 5, depending on how you look at it. And it just like returns you with these bits. So just make a function like that and operate on this using that kind of a function. Okay, so going back to this, what first I think we can do is let's add XORing here. So for example, let's XOR 10 by, what do we XOR it with? 5. And currently when I compile it, it's going to, why didn't it complain? It should complain. It should actually be like, yeah, like no. But it didn't, which means we have an error somewhere. Here, if opt-in, no, it should be a binary operation, I think. Let's disassemble the function for a moment. So let's do, yeah, let's just disassemble it. Okay, what do we have here? We have, oh, it doesn't, oh, you see what it did here? it actually like Python immediately like saw, oh, hey, this is actually a constant expression. I'm going to immediately do the operation before even compiling, like during the compilation. It just calculated the expression, which means I need to, let's call it ground it. I need to base it, like make sure that this actually relies on the result of a previous operation and cannot be calculated in this way. So let's call it again. Yeah, and now it says unsupported operation this, which is absolutely perfect. This is what I want. And I just need to translate this table. I think this is a binary operation, right? Like, yeah, a binary operation. So, you know what, let me actually make a new terminal. Can I make a new terminal? Can I make a, oh yeah, I can make a tab here. So let's make a new tab and have Terminfo here. And let's look for, how do I do an XOR here? Yeah, just with I didn't find it then. Maybe I did a typo. So we have, yeah, these operations, which I guess in Python they look the same way. So an ampersand, a pipe, and a caret. A caret, this is how you call it, a caret. So just doing this should actually make it play music. Yeah, no, wrong terminal, by the way. Okay, now it didn't complain and it actually did get me this operation, so I guess we can how do we put it in a file? Because I want to always put it, I guess, in this ASDF file, which is my definition for the term info. So I just want to put this program here. And the question would be like, do I have, yeah, I have some. So let's do it like this. ASDF, which is like a terrible name. Let's start by renaming it maybe. So ASDF, let's call it Ginvale's experiment dot. I have no idea what's the extension for this. Tick? Terminfo? TI? Let's just go with tick. And this, let's just call it template. And I'm going to call it template because I'm going to do a substitution. So the program which is here, I'm actually going to go with, let's maybe even like, let's do here. Yeah, let's just do like this, like template. And I'm going to load this file, do a string replacement. So here, after I have this output function, right, which just adds to, writes something to standard output. But instead of writing to standard output, I'm going to write to this array, or list rather, output, wow, this is terrible naming, output program perhaps, append, and then whatever is given, we just append it. And then after this compiler runs, what I'm going to do is I'm going to open this template, which again was called Ginvale's experiment template. And I'm just going to read it. So read it into template. And then I'm going to template replace the template, which is in brackets. I'm going to replace it with whatever is the output. And the output is actually, so output, or maybe program, let's call it program. That's the array, but I need to join it because it's a list of strings now and I actually need to join this list of strings. Okay, so we do prog here and we replace the template and now it's like tick. So now let's open another file and write it. Let's write it there. So we do this, open Ginvale's experiment, but without the template this time, tick. And we open it for writing. I don't think there's any Unicode there, right? So it's, yeah, let's, well, maybe there will be Unicode. Let's do encoding equal to UTF-8 in both cases. I don't think that's the default, actually. I think Python does something weird with encoding in the text mode by default. Anyway, let's write it. Tick. Okay, good. So now we are going to, let's just call it. Okay, I guess we can output the program because, like, why not? So let's just like print prog. Okay. Good. And now we should have this, yeah, this one, which should have the template filled with whatever I have written to the program, which is perfect. That's U1. So after running this Python weird, I can compile it. So tick. Did I have to do anything else here? No, I don't think so. I just did tick and yeah, I think I just did like tick and then the name. So in this case, Gunveil experiment tick. And then I can run it. So term equals, or I can do like tput -t Gunveil's experiment and then x. This is now not how you spell experiment. Experiment. Okay, that's cool. Because you cannot see everything I'm typing, so let's do it like a little bit smaller. Okay, Gunveil's experiment and then U1 and then a parameter. So 1, 2, 3, 4, or maybe 10. Maybe 7, so we can actually calculate it by hand. Okay, and it actually works, so let's do like an echo here as well. So this 26 is the result of me running this. So now it compiles it, and it seems to run. Is 26 what I would expect? I don't know, honestly. Maybe, I guess I can run this function in Python as well, right? I just need to provide the out_d implementation, and it's just going to be print A. Okay, so now let's run this with, what was the 7 was the argument, and let's see if it actually matches. So yeah, 26 here and 26 from Terminfo makes sense. It's really nice because, yeah, because I can actually run the function as well. We will lose this capability in a moment, I guess, but that's fine. Cool, so this is working. Now, what else do I have which I wanted to support? Okay, so logical operations. I guess logical operations in Python are really similar in the sense that I think they did put on the stack the value. So okay, so let's try something like this. B equals A, and A we compare A with. I know you don't need the parentheses here, but let's actually put it. And let's see if it's 26. And then we output B, because why not? Let's see how it looks now. Now I need to leave this here as is, and let's run it here. Okay, so unsupported instruction, and we get a compare operator. Good. So it grabs A, grabs 26, and runs compare, and then store fast. Okay, perfect. So the compare op is actually grabbing two things from the stack, and then it has a Boolean value, which is it like returns to the stack as a result of the operation, which is great, because that means that if we actually do almost the same thing as with binary op, but it's even easier, I think. Compare op, and sorry, so for compare operation, we actually support only these ones. So, well, actually, no, this is even worse. I do have to do this, I think. So we either support this, we support less than, and we support more than. We do not support, I believe, we do not support, yeah, like more or equal and or less or equal. We do not support that because the VM does not support that, so we only support these ones. If it's here, then we do, we need a translation actually, because this one is going, yeah, we can do this. It's not ideal, but okay. We can just like grab the first argument. Or I could maybe make a dictionary out of it, but nah, let's just let's just do it like this. It's hackish already. It can be a little bit more hackish. So, okay, and it even works, right? So we compared it with 26 and we got 1 as a result, which is perfect. Let's change this a little bit. Is A more than 26? It is not more than 26. Do we have the comparison in the right order, as in A is 26. So if we put 25 here, the question becomes, well, it should be 1, right? It should be true. A is more than 25. And it is 1, which is good. If it would be 0, that would mean that the virtual machine actually interprets the parameters in the reverse order. And the same question is actually with subtraction. So what we can do here, let's create a... we know B is 26. Sorry, we know A is 26. So what we can do is we can subtract from A 25. And let's print C. The result should be 1. 26 minus 25 is 1. If it will be minus 1, that means, again, like the order of operations is incorrect in the VM. Or rather, well, it just doesn't match what Python does. I hope this is not the case. It is not the case. If it would be the case, it would be a little bit of a pain, because we would have to do some creative swapping of parameters on the stack, which would be annoying, and I really don't want to go that way. Okay, so this looks good. So we have comparisons now, we have bitwise operations. What we are missing is like this if then else. Oh wait, before we go there, let's do not A, and let's print it. So are we still calling it with 7? Yeah, let's call it with 7. Okay, and it says unary invert unsupported operation. Absolutely makes sense. It is unsupported. Is it like unary invert? That's just it. Like, it doesn't say anything else. This is not going to work like in Python, I think. So the meaning of it is going to be different. Op name is this, unary invert. Then what we want to do is we want to output, I think that was just like the same notation, right? Logical and bit complement. So this is a not. And I think not in Python is actually a real operation, which means we should support it as well. We can check it in a moment. Unary invert, we do percentage tilde. So output, just percentage tilde. Like, yeah, that's it. Okay, let's see if it works. Let's leave it as is, and minus 27, and Python says minus 27. Okay, I am a little bit surprised it worked, but that's good. That's good that it works. And now we have not. Not is the logical operand here, so not D. Let's just do not D. And let's print it, and it's going to complain that unary not is not supported. It's weird that it's like there's no unary op. There's like a different, you know, unary invert for one operation and unary not for the other, two different opcodes, while they actually collapsed all the comparison operations into compare op and all the binary operations into binary op. But that's okay. So unary invert, sorry, that's not invert, that's not unary not, is this, and it says 0 and Python says false. Okay, Python actually has a Boolean type, obviously. This virtual machine has only int and string type, where string isn't really, like, not really useful, not really achievable or usable by us. Okay, what else do we need to support? Is there anything else, or do we just go for the if then else? We might support this, but I don't see a strong reason to support it. It would be, where would it be supported? I think it would be in like load const, right? Okay, well, let's do it. So let's do not D here, and then let's add A. And I'm going to actually use the same notation like it's used in C, meaning that it has to be a string of length 1, And yeah, in C, you actually have to use single quotes here, which have a different meaning than double quotes. And in Python, single quotes, double quotes, same thing, absolutely no difference. So, but still I'm going to use the same notation as in C, because why not? So let's run it, and now I should get an exception, but it says that, oh, Python actually throws an exception. That's even funnier. Okay, Python. Yes, in Python this doesn't make sense, which means I cannot run it in Python anymore. And here it says incorrect constant type A, and this is incorrect constant type here. So if type of value is actually a string, then, well, actually we do if len of value is not 1, we throw an exception. Sometimes we throw an exception, I think, raise? No, okay, never mind. I've written like some scripts in between the live streams. So, and I was using like raise exception there. So that's why I got confused. So, character must be 1. Oh, I know, there can be only 1 character. Okay, a little bit of a Highlander quote there. And I guess we can give val here as well. Otherwise, we output percentage single quote value. Yeah, value is just going to be 1 character. It's certain now. It is this, right? It is, yeah, perfect. But no, it's okay. This is fine. This is fine. So let's try to run it if it's fine. Incorrect constant type 3. What? Why is it incorrect? What's wrong with 3? elif. Yeah, it has to be elif here. Though... yeah, okay, that's it. Okay, 65. Is it 65? What am I again doing here again? Sorry. So this is not D. So D was, what was D? D was minus 27. So 27 evaluated logically is 1, obviously. Minus 27. 1 character to rule them all. Yeah, that's a good one as well. We could have used that quote. A plus A. A is 65, so that's 0. Not 1 is 0, so 0 plus 65 is 65, obviously. So this works. Now, do I have any other excuses to not go and implement the else if, or did I run out of excuses and I support everything which is here? I can still add output support first. Output support is going to be a little bit funny, because what I want to do, and let's do it immediately, what I want to do is I want to have like a function, print for example, and then I want to say, hey, actually like E is equal to, or maybe let's go like A is equal to percentage D, B is equal to percentage D, C is equal to percentage X, D is equal to percentage X, because why not? Maybe capital X, and E is equal to, I think it supports octal as well. Yeah, decimal, octal, and well, string doesn't count, so octal, let's go with octal. Okay, and then I want to give it A, B, C, D, E, and I want it to magically work. But this is a little bit more complicated, because I need to, like, these are format string. It's a format string, right? I could maybe do like, you know, in Python you did this, but this starts getting a little bit more funny because we first of all have a tuple here. And this means that the code would create some, like the bytecode would contain this tuple creation, putting 5 things on the stack and then build a tuple, which would like I would have to support additional stuff, so I don't want to do that. Instead, I just want to pass it as more parameters, and this should work fine. Now, let's run it, and it will obviously not work, because, yeah, it says it doesn't know print, but let's look at what is going on here. So, we have call 6, which is okay, and for call we know that print is going to be called. How do we know that? Because, yeah, that's a good question. What's going on here? So, load global. How do we support load global? Load global, here. Value. So what's the value for us? Okay, so the value for us is going to be just print, I think. And therefore, it checks in the array, and it saves it as the next call. Perfect. By the way, after doing the call, so next call is, yeah, here we should actually, this next call needs to be zeroed out, which I don't do. Then we have a load constant with a rather large value, and we just supported load constant with a rather, well, we supported it with 1 character. And this is where it gets a little bit funny, because I guess what we have to do is, regardless of what string we get, we have to preserve it for the next call as like next format, basically. So we create a next format, and we set it to none. To none. Okay, and then we go to load constant, wherever that was. Load constant here. And if it's a string, actually, even if it's not 1 character, we still might not want to exit. I mean, I'm just going to comment it out. It might cause me to not detect certain problems, but let's leave it as is. If length is 1, then we do the output of the character, because this is probably what's going on. If length is not, well, actually, regardless, I'm trying to like figure out how do I differentiate this. If it's print with a long string, like, yeah, just check the length, right? But if I do print X because I want the letter X to be printed, then how do I know whether I'm acting with a, like, working with a string, or if I just want to put it on the here? I don't know that. So you know what, I think I'm just going to lose the, like, I'm not going to support outputting individual values, or rather, I'm not going to support, hey, can I do R strings? No, because they look the same way. That's annoying. Byte, can I do byte? Yeah, let's do it like that. Okay, so let's do it like this. If it's a byte string, then we do what we did. If it's not 1 character, we complain. Otherwise, we do output this. And here I'll just make sure that it's like actually is like this. So if it's bytes, then value of 0 is going to be the byte code, not the character code, the byte code of the first character. I'm losing Unicode support here, but that's okay. And then the character is going to be, like, I'm going to grab the character from that. So this is fine, which means that instead of writing, like here I had A, I'm going to have to write B, A, like this is bytes, and this will work. Good. So now I can use strings only for function calls. So if I'm going to use strings for function calls, for was what? Here bytes. This is good. So let's do elif, type of val is string. Then what we do is next format, we set it to whatever the value is. However, let's do a little bit of an assert here. We assume that next format is known, because if it's not known, that means something weird is going on. Format string wasn't consumed for some reason. Okay. now when we do a call to, well, outd, we will not need it anymore, so I'm just going to switch it to print. And we have, did we have a function table? Sorry. We have func here. Okay, yeah, so we need to do print, change this to print. Okay, we have it at print. And now if we have it at print, what we are going to do is we need to do a couple of things. Now, actually, we only need, honestly, to do one thing. And that one thing is we just need to output whatever is in next format. And then it will magically work, because everything else is already on the stack. So we do this, and we set next format to none, and we set next call to none as well. I think that's it, honestly, for this feature. Yeah, see, it works. Are the values here correct? I don't know. They might be in reverse order. If it is in reverse order, I'm going to cry and we'll have to figure out what to do. And I do believe it's in reverse order. So we'll have to... this is going to be painful. Okay, so let me take a look at the chat. Are you gonna to implement the compiler stack to store print parameters? Yeah, we'll see if I think I'm reaching the point where I might need to do that. Maybe check if next call is not empty. I might want to check that, yes, or I might want the program just to crash. But I don't think it should ever happen that a call is called with empty, because load global has to be called for a function. Okay, so I do have a reverse order, don't I? I guess we can like check it really easily. Let's just like put some constants on the stack instead. Yeah, and as you can see, we have a equals 5 and e equals 1. So 5 and 1. Is there an easy fix to it? There might be an easy fix to it. Okay, so looking at the stack, what we do, what Python does. Oh, Python doesn't put it in reverse order. Python, why are you not putting this in reverse order? What are you doing, Python? No, okay, so this is a Python issue, not a... which is, yeah, like, this is obviously a Python issue. So what do we do when Python is not kind enough to do this? What I can do is, like, I can do a couple of things, right? One thing is I can just say, well, whatever, I'm going to supply to the format string parameters from in the reverse order. Yeah, I can say that. The other thing which I can do is I can do some deferred, but that would be pretty complicated. I can do a deferred. Do I have to do a deferred? We have print here, right? And then we have... Yeah, it would be a mess, because if I have like some operation here, then it would... Yeah, I don't want to do a different... I would have to do like... actually simulate the stack and reverse the order of parameters. I don't want to do that. Like, if this would be, you know, a professional project or something, I would do that, but I want just like a hacky compiler so I can write a simple KrzaQ or reverse engineering challenge. So no, like, what I'm going to say is, yeah, I'm either going to use print with just one format, or I'm going to write them in reverse order. It is what it is. I really don't want to spend half an hour to implement a proper solution to it, and I don't think I see a hacky solution to this one. Especially here, yeah, you could say that, yeah, you can just like reverse the order of load consts, but what if a parameter is actually like 4 plus p1 plus a plus b, for example. Like we have an actual mathematical equation here. So the code becomes like, yeah, I cannot no longer just reverse the order. And I probably cannot even do, like I would have to recognize that when a given parameter is fully evaluated, and I would have to take that as a chunk and reverse it. So a different thing I could do is I could, yeah, just like run prints only with one parameter, and that's fair. So I'm going to leave it as is, and I'm going to say, yeah, that's good enough. That's good enough. Okay, so this works in that case, under the changed assumptions. Python, why would you not put parameters in reverse order? And the stack, I know why you wouldn't, because you try to be normal, not like all the other languages which do that in reverse order. So given that I have this, I think the last one is really the printf. Output percentage. Yeah, because if I, like here, if I want to actually output the percentage, I do have to write 2% anyway. Like it would be a format string, so I'm going to try to remember that. I could write some checker, but I don't want to, so that's fine. And now if then else, which is going to be a mess anyway. Yeah, I see on the stack you are also saying to not implement it. Yeah, I don't want to implement it either. And what's this, by the way? Right, I have this one. We played with it yesterday. Cool. So now let's make an if then else. So for example, let's do, I'm going to like preserve most of this code. Oh, I wanted to do this, but I shouldn't do this because this would actually emit a, no, it wouldn't. Oh, it would change it to a doc string. What will happen if I do this? I'm out of curiosity, and let's just print ASDF. Otherwise, yeah, it doesn't go into code. It goes into doc string. This is okay. So what I want to do is, let's do it like this. If p1 is equal to 42, I want to print great work. Otherwise, I want to print nope. So, you know, like let's just assume it's a flag or something. And now let's compile it. Obviously my compiler will say, yeah, like, what is this pop jump if else if false you want to employ here. So when we have this opcode, what we get here is, what do we get as a value for this anyway? Oh, I closed my console. I did not mean to do that. Okay, thankfully it didn't break anything. Good, so let's just copy it. And this is going to be a little bit more hackish, even more hackish than I already have. So elif op name is this thing, then we do, did I have like this print here? I had a print, yeah, this print, which I could use here. Just print it and then just exit. Okay, so 36 to, wait, what? Okay, it's kind of my mistake, but I didn't do, let's just do something like this, so I actually know what is what. Good. Okay, yeah, so value is 36, and 36 is here. This is a jump target. So I might have to do this actually in two. No, I don't. Okay. So, no, I don't, do I? If something is a jump target, and I think I can tell if it's a jump target, we did look at the Python documentation last time. So Python docs this. And there was something about being a jump target or branch target. Is jump target. Yeah. Of a jump target, okay. So let's just print it here. Oh, let's just print it here. It's going to be false, but that's fine. No, this is fine. Yeah, it's going to be false, but it exists, and this is the important thing. So, this works the following way. Oh my, this is bad. I need to get a structure of this in a little bit of a higher level. Honestly, I kinda need like AST level here. Because what I need is I need to know which code belongs in the then branch, let's say, and which belongs in the else branch. And I don't think there's an easy way to do it from byte. Well, that's not true, of course, right? There's a pretty easy way to do it. But what if I don't do it like this, and instead I look at the AST tree, AST like abstract syntax tree? Then I would actually have the if-else handed to me in a pretty nice way. And maybe then I could compile only blocks of code which... Yeah, that might actually be a solution. So let's import AST and let's work from there. So, okay, Python AST, because I obviously don't remember how to use AST. If you're wondering what is AST, AST is like before the code is translated to bytecode, it first has to be translated from this form into an abstract syntax tree, which is not yet compiled, but not source code. It's like a tree, like the name implies, or rather is like more like a list of trees. Every statement is one tree, and then the tree is basically like, oh, like if you have this kind of operation, for example, then is like a node, which is a comparison with two children nodes, which one is like P1 and the other is 42. So what I would have to do is I would have to run this compiler recursively for every if-else. Good thing is that I don't really support anything else apart from if-elses. So, okay, there should be an example here. Okay, so it's just like parse. Do I want to run parse on it? Yeah, I think it's fine. So, therefore, let's go back here. Let's do exit here and let's play with the AST tree for a moment. No, it's not parse. I think I need to move it to a different file, like this function now. And I need to open that file and I need to start parsing that file. Or can I just give this function to AST? I don't think so, right? It has to be source code, I think. So putting this in a different file makes a lot of sense in that case. So let's do that. Let's create a new file, which is called, what are we going to call it? Like example py. It's not really Python, right? But let's just call it py. Okay. Now let's do the most Java thing possible and maybe like let's call it main. I wanted to call it like the same name as the file name is called, but not. But maybe not. So okay, we have it in a file. Good. Now, if we have it in a file, I don't need this anymore. Did I copy everything? No, let's just like copy everything. So I have it here. I'm going to ignore these like large doc strings, I think, unless they even... Do they even go to AST3? I don't know. Well, if they do, you know what doesn't? A comment. A comment does not go there, so let's do this. Okay, therefore, I don't need this. What I need is I need to open a given file, so xqi. Read it. I don't think like I need to declare the encoding, but let's just do it and let's read, and this is going to be my source code. Now, for the... This is fine. Okay, now the function is always called main. So now we can do AST parse and we can do a dump, and let's take a look what we get. So I'm just going to like literally copy this code. Let's call it T for tree, and we do T, and I think there's some settings for like indentation and show empty. Let's do that. I'm thinking really hard now, when was the last time I played with AST, but that was pretty frequently, and I don't remember why did I play with AST not a long time ago. I was doing something weird, obviously. Okay, so, okay, it doesn't, wait, what? Get an unexpected argument. I have an old Python here, and I'm looking at documentation of the really new Python. I have 3.12 here. Okay, which means it probably was called something else. So dump has, yeah, it doesn't have. It has indent, but about, like, it doesn't have show empty. So that's okay. Cool. So we have this abstract syntax tree. We have a module, and the module has one function. The function is called main. Yes. Then it has some arguments. We don't care too much about the arguments. What we care about is the body. The body is a list of statements, and the statement, first statement, there is an if, and it has a test comparison. Oh, this is absolutely amazing. It has a test comparison, because, why is it amazing? It's amazing because they actually here in this VM, they want the expression to be also calculated here, and I was thinking like, hey, can I like just pop the value from the stack and use it as an expression or something? But they are fine with calculating it, so that's good. I guess it can be calculated before the if, doesn't matter, but it's because we have like it in the test child, let's call it, of this node, then yeah. So what we want to do, and you could also like, if we, let's just go to the body, the first function, there needs to be like, we can do a couple of tests, I guess, like, so let's do it like this. Print t, because okay, so it's an AST module, good. So this module has a body, which is a list. Okay, good. Now, the first assert we are going to do, or maybe check, is if t body, the length of this, the number of statements in the module has to be 1. It just needs a list, nothing more. If it's not equal to 1, then we do sysexit AST error, and we print, what do we print? We say like, source file can have only one function called main. Okay, good. So now we have this function, which I hope is actually a function. So the next thing we probably should check is, hey, is this a function definition? So we do if is instance, that was how it's called in Python, func of this. If it's not an instance, then yeah, like we do this again, like this is exit. Okay, for so far so good. And then it also needs to be called it needs to be called main, so the name of the function needs to be main. Does it need to be main? Not really. It doesn't matter. So no, I'm not going to check the name in that case. Okay, then the function obviously has some arguments, we don't care. And it has a body, which is again a list of statements. So for list of statements, okay, so for statement in function body, let's just do print the statement. We only have one statement there, but if statement. Yeah, only one statement. Nothing else. Everything else is the result of a dump. And we care only about. So okay, there are two types of statements we care about. Ifs and anything else. Anything else can be basically left for the compiler to be compiled immediately. And an if needs to be compiled separately. So the code which we have written before, this code will need to be, we need to put it in a function, but we can do it in a moment. So before we do that, I need the reverse function of AST parse. I think that was like unparse, deparse, something like this. Unparse? Unparse, there we go. Warning. Okay, yeah, that's fine. So what does unparse do? Unparse grabs a node and converts it into a Python function. Like Python source code, actually. So I have like this if, for example, right? And I can do AST unparse of s, and it will give me a string which is equivalent to the source code of this, which is like this, for example, right? So this is actually amazing, because what I can do is I can do three things here. I can grab like the test, the source code of test, yeah. Then we can grab the source code of, how do they call it? Body and or else, okay. And then we get the source code of body and the source code of or else. Now body is just well, body is just a list again, and or else is also a list. Too bad. I didn't want it to be a list, but apparently it is a list. So can I just give it a list of expressions, by the way? Well, we can, one way to find out, right? Like, let's do body and let's do or else. It works. Good. I was worried that it won't work with a list and I would have to do some hacking, but okay, it works. Cool. Okay. So now what we need is we need this to compile. Yeah. Now, there's like one small problem, which is that, which is called local variables. Because what I want to do, right, is I want to like give it, for example, this comparison, and I want to feed it to the code which we created before, or rather I want Python to first compile it, and then I want it to feed this assembly into the code which we had before, which would just like give us the equivalent in the VM for this code. Great, right? Easy. Now, the problem here is that it will, if we use, for example, let's assume that we have a function like this. A equals P1, right? Everything is good. A, like we create this local variable A here, and then we here do B equals A. Makes sense, A local variable, no issue. But if we compile separately just this body of if, then Python will be like, hey, I have never heard of this before. This needs to be a global variable then. Otherwise, it doesn't make sense, right? But no, a is a local variable. We know that a, b, c, d, blah, 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 up to z are local variables. So we have to convince Python somehow that all these like a, b, c, blah, blah, blah are local variables, not global variables, when it's compiling. We are not going to use eval. We are going to use, because eval is for expressions, and we need it to compile statements. Like for example, yeah, this isn't an expression in Python, right? This is a statement. What's the difference between a statement and an expression? An expression is an expression evaluates to a value. A statement doesn't have a value. So if else, that's a statement, right? But like this, for example, that's an expression. So a statement can be like made out of expressions, basically, and every expression by itself is also a statement. But a statement isn't an expression. So, and I'm saying like, but every expression is a statement because if I just write P1, this is valid Python code, which is just an expression, and an expression again is a statement. Yeah, like theory of programming for you, which is actually like applied theory of programming here. Now, yeah, so we have to tell Python, oh, we have so many variables. How do we tell Python that? We are going to tell Python that in like some absolutely ridiculous way, probably. So let's just go here for a moment and let's tell Python to compile something for us. So Python docs compile. I think compile is what we want. Not eval, because eval is for expressions, but compile. And compile can, yeah, so we can give it source. And let's give it source like a equals 42, for example. Then we have to give it a file name, doesn't matter, it can be like, yeah, like string, for example. Then we give it the mode, and the mode is exec, I think, for us. Exec is source of consists of sequence of statements, eval of a single expression, see, as I told you. And single contains a single statement. Interactive statement. No, we need exec. We need like this to be, this can be multiple statements. Or are they multiple statements? Maybe we can get away with one statement. But let's go with multiple statements. What's a single? If it consists of single interactive statement, in the latter case expression statements that evaluate to something other than none will be printed. Like printed automatically? That's funny. How does it work? Let's test it. Python compile, and let's give it like a equals 43. And we do it like a string. And then mode is going to be single. Okay, so we get a code object. Okay. And what is this code object made of? Oh, I didn't assign it to any variable. Okay. There's the C. It's okay. Now I'm curious about one thing. Load name A. Call intrinsic print. Okay, so yeah, it actually calls print. Wow. That's funny. So yeah, we don't want single. I thought we could use single because it would maybe use, like, not use global variables at all. It wouldn't use load global. But apparently that's not the case. So yeah, we use exec here. And exec is going to do load name. Load name isn't bad. Yeah, load name we can work with. I was worried it's going to use load global, but it uses load name. Why does it use load name and not load global? Which is an interesting question. And I don't think I have an answer to that question. Because if we would, like, if A would be a function, it would do load global here, right? No, it also does load name. Push null. Why does it push null? What's going on here? What if I do print? It did load global in our case, and here it does load name. Maybe, oh, I know why. Because another parameter of compile is the global. It's not. Okay, that's weird. So yeah, like my problem is that if I have a function which is called x, for example, and the only thing I do there is print, and I do this on x, it's going to be load global here, which we support. We support load global right now. We do not support load name, but that's okay. Load name is not tragic. I don't mind it being load name, honestly. Because we can just like, yeah, we can work with this. This is fine. Okay, good. We don't have to do any hacky things. Just have to change the compiler a little bit. Here I obviously wanted to do this. Okay, so given this, what we do now is we have to put it in a function. So let's put it in a function. And let's call the function like, and we need to put it in a function because we are going to go recursively into this. So let's call it like compile prog. And what it's going to get a node. And what it is supposed to return is supposed to return a string. So a node, what is it going to be a node? It's going to be, yeah, what's a node? What is it getting? I'm guessing it's getting a list, actually. Every time it's going to get a list. Yeah, let's do it like this. Every time it gets a list. So nodes, it's going to be nodes. Perfect. So what we do at the end is we're going to do compile prog, and we are going to call it on the function body, which is a list of elements, so nodes. And then this was obviously for something else, so let's just do this. Okay, now a node can be an if, or it can be something else. So let's start with just printing s. So, or actually, I already had like the name if, ast if. Okay, so never mind. I can just do here if is instance of like this node. This why is it called s? N node of an if. Then I do something. Otherwise, I actually run compile on it. So I'm going to have some kind of an output string. And at the end of a function, I'm just going to return that. Why am I like using a list here instead of doing, you know, like creating a string and then doing this, for example? I could do that. It doesn't matter in this case. It's like, this one is just faster. Like appending to a list is faster than appending to a string for reasons. So otherwise, what I need to do is I need to actually compile the string. I know it's going to be one statement, which is not an if, which is probably going to be an assign statement or function call statement, something like this. So I'm going to do compile statement, compiled statement. Okay, and I'm going to pass it that single node, and it will return me a string. And I'm going to output, like, add that string to output string, like this, with append, I mean. Okay, if it's an if, then it gets funny, because I have actually three things. I need to compile three different, well, not really even statements. I need to compile an expression into statements. So let's start with, yeah, I'm just going to call it compile statement anyway. As I said, an expression is a statement anyway. So first of all, we grab the test, right? And the test is going to be test. Then we get the, how do we know if an else if is actually empty, by the way? Can I run it? Does it crash? No, it crashes. Because I have this thing which I didn't finish. Okay, not define, that's fine. I wanted to just look at the output. So body is something and or else. Okay, if or else is empty. So I'm going to comment this and comment this. How does it look like? It's just an empty. Okay, okay, that's good. It's an empty list, which is fine, I guess. So we know we have a body here. Now, or else might be nothing initially. The body might be empty as well, actually. Let's just compile it and let's just like see what happens. But it doesn't have to be one statement, by the way. This one is going to be one statement, like the test, right? But everything else can be a program. So for everything else, I'm going to need to call this. And the same here. So yeah, let's just do this, or else. Okay. And at the end of the day, what I'm going to output to the string is, what was it? Extend? Expand, extend. Okay. If I want to like add to the array multiple arguments, I think let's extend. And let's go. We start with, well, we basically have to do this. Yeah, this is what I wanted. Okay, so we start with this. Then we give it the expression, which is called the test here. Then we give it then the then part, which is body. Then we give it else, and then we give it the else part. Now, the else part might actually be empty. So I could do an optimization here, but I don't think I care about that. And at the end of the day, we have to finish with this anyway. So let's just do else part anyway. Okay, this looks nice. So now what I'm missing is this compile statement. And the compile statement is what I've already written. Do I need parentheses? Where do I need parentheses? I'm not sure where do we need parentheses. If you're asking if we need them here, we don't. If you're asking about something else, just like please hint me what is the question, because I don't know. Good. So now we have this, and now let's create this like def compile statement, which gets a single node. So this is a node. Now, if we have a node, that means we can compile it to Python code. So we first compile it, ast and parse node. Good. Then we need to compile it. So we do this this thing. This is the source code. We have a string, we have exec mode. We don't give it any more arguments, I believe. Is there any other argument which I could give it? Flags.inherit. I don't know what's don't inherit actually. And optimize. Flags. What are the flags? Can I give it some flags? Flags. Hello? Where are you? Compiler options, which should be activated. I'm not touching it if I don't have to. Okay, so we have C for compile. Now we compiled it and we get a code object. We get a code object for nested ifs. No, we actually don't need parentheses for nested ifs. We did look yesterday at the what's it called? At the source code of this virtual machine, and it did some funky counting of how many times this and this appear to figure out what is the level of nesting. So yeah, we we don't have to do it because these act as braces basically, or indentation level in Python. Okay, so here we compiled it. Now that we compiled it, we basically go back to our old code. So our old code is like, we don't need this anymore. We have, yeah, this is getting a little bit funny, but okay, let's do it like this. We disassemble the C, what we have just compiled. This is obviously like, this is fine. What do I have to do here? Now it's going to do the load name, so it's going to access this. This is okay. And then everything else I have to indent by 1 up to this point. I actually wanted to, command, yeah, to do this as well. I don't need to do this until here, perhaps. I'm going to do an exit here because this isn't going to work anyway. I'm going to do an exit 1 so that the rest of bash line doesn't execute. If this returns 1, when this does not get executed, echo gets executed because it's after a semicolon, which you cannot see because it's again hidden by my camera. I apologize for that. There we go. Okay, so now we have to do a couple of modifications here, or do we? The output program we append to it, and here we set prog, okay, and then we just return it, prog. Good. So this is the only thing which is actually outputting any opcodes, actual opcodes apart from this, which is how it should be. Okay. So this won't work because it will complain when I run it. It will complain like, hey, what's up with like load name? I have no idea what load name is. Good. So what I need to do is I need to do compile program and I need to run it on func. I'm guessing like everything which I have here should be just like called below. So I'm just going to move this code. Let's move this. I actually don't need this. Ignore op names. Yeah, I can leave them there. And everything else goes here. Okay, let's run it. I'm actually closing my eyes. Function definition is not iterable. Right, because I'm giving it only a single thing. It complains, so I'm just going to give it like it in a list. It's fine. Okay, good. Incorrect constant type. A code object main. Wow, this is really an incorrect constant type, not gonna lie. What are you? But why? Okay, so let's go here. And we are doing this bytecode C, and we should have like this bytecode here. Let's, you know what? Let's call it print this C and see what we are getting. Okay, so we first. Why is this being? Did I do a body instead of func? No, I'm doing func. That's weird. It is a function, right? Am I using a variable name? No, it's n. This is not. This is fine. I have some stupid mistake. This is like not a. No, let's do clear here as well, so I can scroll up. Okay, this is fine. Now. AST function definition. This is good. Oh, because I'm doing. I get it. I cannot give it a function definition. I need to feed it the function body. Yeah. Yeah. No, yeah. There we go. Okay, so then we have load name P1, store name A. Did I change the code? Oh, yeah, I did this. Okay, that's fine. And it has this load name and store name, which I do not support, because they are identical to load fast and store fast. So if op name is store fast, or op name is, oh, you know what? Like, if op name in, let's make a set, store name. Then this is what we do. Else, if there is one problem with what I'm doing, and it's going to bite me in a moment. Where is the load name? That's the same as load global? No. Load fast here. In load name, then do this. Push null. Why is it doing and push null? I don't care about push null. Like, what are you doing? Yeah, like, go away. Okay, good. Incorrect variable name for load print. Really good. This is exactly what I was saying. Is that because of the changed environment. Now Python thinks that it's compiling this code. Previously it was compiling the code in a context of a function, and it knew that. Now it's compiling this code in the context of a module, a global code, if you will. As such, it will actually what? Not use load global as it did before, but it will use yeah, so it will not use this load global. Instead, it uses load name. So here, if it starts with P, then something else, elif, length of, or yeah, I know, if it's in function table. Maybe I should even start with this. Because no, it's hard enough. Oh yeah, let's start with this. If it's in function table, then we do next call is value, and this will be fine. Okay, we are getting somewhere. Now it prints none because I did not return something somewhere. Where did I not return something? Here I returned the output string, which means that in compile statement I might have not returned. I do return the program here. What's wrong with you? Okay, so this is fine. No, maybe it works. Maybe I'm just stupid. It actually can work. I might be like misreading one thing. Let's go here. Okay, here p or rather prog, and let's move this here. It might even be working. Yeah, it does something. It does something. So. Oh, Adrian has a good point. Can I exploit the AST to invert the call parameters for print? You have a point, Adrian. We could do that. On AST level, this is way easier. So I might do that. Not yet, but I might. Okay, so let's look at what we have here. And this looks good, does it? We take P1, we store it in A, then we run an if, and we check if P1 and 42 are equal. If they are, then we are putting B. What's BB? Oh, we are getting parameter A and putting it in B, and we are outputting great work. Otherwise, we are outputting nope, and we are ending the else. This looks good. Yeah, this looks good. So let's do this, exit, remove exit, and now let's run it again. And it says nope. Okay, so I have 7 now here as an argument. Let's change this 7 to 42, and it says great work. Hey, it actually works. This is absolutely amazing, because this is such a hack. It's like why does it work? Let me comment this out. Comment this out where our prints are, by the way. And we do this dump here, we don't have to do it anymore. Yeah, yeah. We change it to, I don't know, 41. Nope. 42, it works. Okay, let's check with actually... let's check with 2 things. First, I'm going to check embedded ifs. If really embedded ifs work due to this recursive action which is going on here. So if p2 is equal to 51, then I don't care about this. Then we do print great work. We are not creating an else here, or actually, yeah, we maybe should as well. Print also nope. Okay, let's see if this works. It did compile something. For 42, it says also nope. I need 2 parameters now. So for 42, it says also nope. For 40, it says nope. For 42, and what was the other value? 51. Why is it 51? I don't know, but great work. Yeah, it works. So can I do it a little bit more? Is it a little bit more fun in that case? So let's actually make a crack me right now, like a simple CTF challenge, because we are super close. Let's do it like this. For A, we say P1, and we actually XOR it with... yeah, if you're doing such kind of a crack me, you probably need something that will calculate values for you. So X calc py. Okay, and now let's do, I don't know, let's assume that A is supposed to be like the value which we want. We want this value. B we want, oh, actually let's make it a little bit even longer. Let's maybe just grab like some random values. So Python import os urandom. Let's grab 3 bytes, 4 bytes. I don't want to grab 4 bytes because it starts being a little bit funny. With the most significant bit, I mean. Let's grab 3 bytes. No issues then, and then let's represent them as hex, and let's grab a couple of them. Okay, so these are the correct values for us. X is 3 bytes. Okay, it is 3 bytes, good. And now we like said that A, B, C, D, and E. And now what we want to do, for example, we want to grab some more 3 byte values. Okay, and these are going to be keys, basically, which we are also going to use in the source code. So we do A, we XOR it with a given value, and obviously by A I do mean ABCD. Good. Yeah, that's okay. Like, this is enough for a simple challenge, I think. And then what we need to print here is basically the value of A. Do we want it decimal, hexadecimal? Doesn't really matter, I think. Let's say decimal, because I don't care. Was it A equals or equals A? I think A equals. Okay, good. So now let's run it. Python x1 calc. Xcalc? Yeah, xcalc. Okay, so these are the values which I need to put in the source code. So let's put it like this. Do I need to actually put them in variables? I don't know. Let's assume I have to. So, okay, these are the keys. Now, if P1 XORed with A is equal to the correct value, and the correct value I need to copy actually from here. Now, this should work because Python, the compiler, will actually change it to a value anyway. And ends should work, and they should translate into else-ifs, as I showed you previously. Which kind of means that I can just write code like this. 2, 3, 4, 5. Okay. And now I need the other values, so let's just like grab them all. Good, and now let's here grab them all as well. Okay, good, good. Then we print great work. The flag is, and we give it a flag, right? But the okay, so the flag is going to be probably the values of P1, P2, P3, and P4. So like, for example, CTF, or like, let's go with hexa for, because I want to put it on HackerCana, as I said. And we do %x, perhaps. Was this the key, or was this the value? These were the keys. Yeah, I copy-pasted the wrong thing, I think. Well, no. It's whatever, actually. Yeah, whatever. These are the solutions in that case, and let's assume these are keys. It's going to be just a little bit easier. Okay, yeah, this is going to be a little bit better. And then what is printed is actually the solution. Sorry, the solution. Yeah, the solution what I have to give here. Okay, let's say these are like decimals. So %d, 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 %d. Or let's do it with x, 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 because why not? And then in reverse order, because again my compiler is not great, I have to do P5, P4, P3, P2, P1. Good. Okay, so this is a decent program. Let's compile it. Unsupported instruction copy. This sounds scary. Let's disassemble it and like just see where exactly does it complain. Before I'm outputting this, I should actually do okay. Copy. What does copy do? No, seriously, what does copy do in Python? I don't know. I'm worried because this sounds like duplicate one parameter on the stack, and we don't have an instruction like that. I don't think we have any instruction that would be useful there, so this might be unfortunate. Here, copy. Copy I. Push the ith item on the top of the stack without removing it from the original location. No, this will be annoying. So it puts the one of the arguments. What does it put actually on the stack? What is 1 in this case? Like 0 is probably the result of this. Oh, 1 is going to be P1, isn't it? So, because for print, where's the print, by the way? Oh, there's no print here, because this is just, what is it? No, wait, there's something wrong. I should never see this. I get it. Okay, I get it. I cannot use ands and ors, because when I'm using ands and ors, Here, thank you. Yes, I indeed have like 5 A's. I don't think this is an issue. The issue is that, like, one of the issues, I have 2 issues, actually. One issue is that, and I cannot use AND, because my support in the AST tree is not for AND. It's only for if-else. So I actually have to use 5 ifs here. I can use 5 ifs, I don't have to use 5 ifs. I can change it a little bit, but okay, because I have like support for ifs, let's just use 5 ifs. So if this, and if this, and if this, and if this, and if this, then do the print. Okay. And then I need like a lot of else's, I think. Else. Nope. Else. Nope. Else. Nope. And else here. Nope. Okay. This is a little bit disgusting, but okay. Okay, now it compiles, and that's good. So okay, if it compiles, let's try to actually run it, like just this. Nope. Okay. So what are the proper values, actually? Actually, that echo at the end might not have been a bad idea. The proper values are whatever was printed before by that program, so Python xcalc. Okay, these are the proper values. So, this is annoying copying thingy. Yeah, okay, whatever. Just going to copy paste them manually without double clicking like an animal. Okay, yeah, so it does work. Apparently. Yeah, seems to work. Cool, so we have one challenge. And I guess what I can do is I can like change the numbers and put it on HackArcana, so I'm probably going to do that off stream. Maybe tomorrow even, it's pretty late already. But we have a compiler. It's not perfect, obviously, but it is good enough to make a little bit more even convoluted challenge, a little bit more interesting challenge. But I'm pretty happy what we have achieved. Now, I might be doing one more live stream from this, because what I wanted to do, like, this is pretty long. And I actually wanted to, like, write an article about this to PageOut, to like using a hacky Python, abusing the Python compiler to generate code for another VM. But PageOut is a one-page. It has a one-page limit, right? And there's no way this code fits on one page without some code golfing. So on the next live stream, I'm just going to code golf this code so that it still works. And I can put it in PageOut, but I don't like, it's not so long. So I'm probably going to remove a lot of things. I'm going to optimize size-wise some other things. So there we go. Okay, so for today, that's it. Thank you for being here with me and suffering with me through this hacking up the Python compiler to generate, or rather Python introspection into what Python's compiler does, in generating Terminfo VM language, bytecode, whatever you want to call it. Cool. So that's it. Thank you for being here, and let's. There's not going to be a live stream tomorrow. I'm not sure about the weekend, but maybe as early as Monday. Now, as I mentioned, actually, the next days, next week, like from Tuesday to Friday, every evening, I have a live stream on, like, in Polish about basics, like intro to Python in programming, like really basic stuff. In case you want to come, you have to register at, where's that website here, at like sklepsecuritum.pl/stamp.pythona. And yeah, so I'm guessing I'm going to live stream only Monday next week. And then, unless I have time after some live stream or before some live stream, and that's not really expected. And if you have an account on HackerCana, I'm going to push the Terminfo challenges there. Maybe over the weekend there will be in the exercises tab. So if you have everything else solved, like all the other challenges, just like there will appear somewhere here. I'm probably just going to make some stupid pun with terminal or terminator or something like that. Amazing. So that's it for today. Thank you again for being here and have a great evening. And that's it. Bye-bye.